In lesson 5.4, we're talking about relationships between the sides and the angle measures, okay? Along with that is we're going to determine if we can make a triangle out of specific sides given to us. So I want to play around with that for a second. If I picked 3 sides from here, again, why am I picking 3 sides? Because it's a triangle, okay? So if I pick sides with length 6, 7, and 10, do you think those 3 sides can make a triangle? It does not need to be a perfect triangle. The corners just have to connect to each other. Do you think I can make a triangle out of those 3 sides? Raise your hand if you think yes. Raise your hand if you think no. Raise your hand if you think yes. I'm going to give you another example. If I had the sides 2, 4, and 10, can those 3 sides make a triangle? Raise your hand if you think yes. Raise your hand if you think no. Why do we think no on that one? What do you mean by that? That's exactly right, okay? He took the 2 smallest sides, 2 plus 4. What does that give us? 6. Can 6 cover the distance of 10? No, so these could not make a triangle, okay? With these ones, if I take these 2 smallest sides, 6 plus 7, okay, that gives us 13. Will that cover the distance of 10? Yes. Okay, I'm going to give you another example. If I did 4, 6, and 10, do you think those sides could make a triangle? Let's do the strategy we did above. 4 and 6, add those together, what do I get? 10. I agree those are equal. However, this would not connect. Okay, so everyone write this down. To know if triangles create, if the 2 shortest sides add up to be greater than the longest side, then it is a triangle, or it can make a triangle. Okay, key word is greater than. Okay, because of the example of this, yes, 10 equals 10, but the 2 shortest sides, the sum of those has to be greater than the longest side. Cannot be equal to, has to be greater than. Okay. I'm going to throw one more example out there. I do 2, 3, and 6. Can those 3 sides make a triangle? Why not? What's the reasoning? What'd you say?
2 and 3 can't add up to 6.
Right, 2 and 3, what do they add up to? 5. Is that greater than 6? No. Okay, so the 2 smallest sides added up together have to be greater than the biggest side in order to make a triangle. Okay? Moving on to this, okay? We are going to talk about relating side lengths to their corresponding angle measures, okay? So looking at this first triangle right here, what is my smallest side? 5. So do you agree that is side AC? What is my next smallest side? AB. What is my largest side? BC. Okay, because this is 5, 12, 13. Okay, from smallest to largest, those are our side lengths. Okay, how do you think the angle measures relate to the side lengths? So which one of the angles out of A, B, and C is our smallest angle? Why do you think B? Why did you say B? Because it looks the smallest? I agree. You are correct. B is the smallest. What is the relationship between the smallest side and the smallest angle? What's the relationship between them?
Between the smallest side and the smallest angle?
Yes. What's the relationship between the smallest side and the smallest angle? It's across from each other, opposite. Okay, so the smallest side AC is across from the smallest angle B. Okay, so AB if we finish this out, what is my next largest angle?
Next largest.
Next largest angle. So AB, it'd be across from AB, right? What angle is across from AB? C. And then what is my largest angle? Why is A my largest angle?
Because it's across from CB.
Because it's across from CB. Okay, so they relate to each other because they are across from each other. Okay, if you think of this, if I have a side length of 10, pretend my arms are a side length of 10, does the angle across have to stretch pretty far to reach both of those corners? Okay, if I have a side length that's this big as my forearm, okay, does that other side have to stretch as far? No. Okay, so you see how the angles and the sides go together? Okay, looking at this one right here, what is my smallest side?
No. Yeah.
Right? Why did you say both of them? Because they're the same. So PR and PQ, yes, they are the same. It does not matter the order you put them in. What is my largest side? RQ. So what are my smallest angles? Because they're across from the smallest side. So R and Q are our smallest angles. What is our biggest angle? P, because it's across from 10. So example 1, I want you to write the angles from smallest to largest. Okay, so always start with the smallest side since we're going from smallest angle to the largest. What is my smallest side length? MP, which is 8. What angle is opposite of 8? N. So N is my smallest. What one would be next? Yep, 23 is next, so it would be P. And then what's my largest angle? M. Try example 2A and B on your own. Okay, so looking at example 2A, if I'm looking for the largest angle, what is it opposite of?
The largest.
The largest side. What's my largest side?
DF.
DF, which is 14. What angle is opposite of that? E. So E is our largest angle. Smallest angle, what are we looking for? Smallest side. What is opposite of 8? Angle D. Okay. Okay, on example 4, looking at this one right here, do we have enough information to answer the questions right now?
No.
Why not?
Because we don't know the O angle.
We don't know the third angle. Okay, so how can I find the third angle?
65 plus 58.
Yep, because what do all of these angles add up to? 180. So we can do 65 plus 58, which is 123. And then 180 minus 123 is 57, sorry. 57. Now do we have enough information to answer A and B?
Yeah.
So longest, the side that's longest, what is it opposite of?
The side, the angle that's
The angle that's the biggest, okay? So our biggest angle is 65. What side is opposite of 65?
QP. Oh yeah, sorry, PO.
PO or OP, either way. Okay. What side is our shortest? What do I look for? The smallest angle. So what's opposite of the smallest angle? NP or PN. Good. So those relationships are just opposites of each other. Looking at that habits of mind question on your notes under example 4, it says in any triangle with a 105-degree angle, is the longest side always going to be opposite of that angle? So what they're asking, in any triangle with an angle of 105, I'm going to say that's 105, is the side opposite of that always going to be the largest?
Yes.
Why do you say yes?
Because that's over half of 180.
Right, that's over half of 180. So can those other two angles be greater than 105? No. Okay, so that longest side would always be across from 105. Good. Okay, another thing, last thing we need to talk about is, we've kind of already talked about it, okay? If I had these 3 side lengths, Okay? How can I determine if it's going to make a triangle or not?
If it adds up to greater than the largest.
Right. Want to pick the smallest ones, which is 18 and 19. If I add those up, what's 18 plus 19? 37. What does it have to be in relationship to the larger side? Has to be greater than. So, can these three sides make a triangle? No. Okay. Looking at this one right here. How do I figure out if these three sides can make a triangle?
33 plus 37.
Yep. Take your smallest sides. 33 plus 37 is 70. What does this relationship have to be?
Greater.
70, or this answer right here has to be greater than your biggest side. Is that true? Yes. So this can make a triangle. Okay. And that's a triangle inequality. Okay. What that means, does anyone know what an inequality means? Or what I mean by that word? Could be equal. Greater than, equal to, less than, all of those different signs. Okay. Those are inequalities. The reason we use those for this is because can x be more than one number to make this true? X can be any number. That's why we're going to use inequalities, okay? Our goal with these is we're going to find the range of where x can be. X is going to be this or this number or the numbers in between, okay? How do you think we can figure out what x is? What do we know x has to be?
Greater
That
than.
has to add to 11.
It's gotta be greater than 6 or greater than 5.
How do you know 5?
Well, because 11 plus 5 is 16, but then it has to be greater than
Right, so these two sides, what do those two sides have to be greater than?
16.
16, right? So 11 plus x we know has to be greater than 16. So how can I solve that inequality?
Minus 11.
Subtract 11. So we have x is greater than 5. That's one inequality. Now we need the other part. What's another statement that we know has to be true? What'd you say?
Has to be less than 16.
What has to be less than 16? Not necessarily. What do we know about these two sides? Right, when those two sides that we have add up, they have to be greater than x. So we know 11 plus 16 has to be greater than x. So what's 11 plus 16? 27 is greater than x. There is our two inequalities. We know x has to be greater than 5 and x has to be less than 27. Does anyone have an idea of how I put that into one compound inequality? Here's a hint. You're always going to start with your smallest number on the left, biggest number on the right,
Oh, I got it.
x in the middle.
You gotta put your 2 in it. And it's just that you just
Yep.
combine them.
Yep. What I did is I just took this inequality and this inequality and put it into a compound inequality. Okay? So what this says is we know x has to be greater than 5 and x also has to be less than 27. So this is the range that x has to fall in. Okay? So what I'm going to ask next, can x be 5 or 27? Why not? Because it has to be greater than, right? If it was those, it would be equal to, but we want it to be greater than. Okay? I want you to go try. All right, so on 5A, it gave us 16, 39, and 28. It's asking, can I have a triangle with those side lengths? How do we figure that out?
16 plus 20.
Yep, take your smallest sides, 16 and 28. So 16 plus 28 is
44.
44. What does it have to be?
Greater than 39.
Right. This sum has to be greater than the largest side. Is that true? Yes. So yes, those three sides can make a triangle. Okay. One more thing we got to talk about today on 5. Okay, similar to what we just did. What will help if you need to visualize, draw yourself a triangle and label sides. So we have sides 30, 50, and x. Write a compound inequality for the range of x. Okay, so let's talk about this. The goal of this compound inequality is we're finding the range for what the value of x can be. Okay, what is one inequality that we know has to be true?
X or 20 must be greater than 20.
How'd you get that?
minus 30.
Right, because we know 30 plus x has to be greater than what?
50.
50. Okay, so 30 plus x has to be greater than 50. So then how do I solve that?
Minus 30.
Subtract 30, right? So we know x has to be greater than 20. How do I figure out the other half of that inequality? What's another true fact that we have to prove? What'd you say? How'd you get that? Right, we know these two sides have to be greater than x, right? So we can do 30 plus 50 has to be greater than x. So 30 plus 50? 80 is greater than x. So x has to be less than 80. How can I put that into a compound inequality?
20 is less than x, which is less than 80.
Yes. Good. That habits of mind question at the bottom of your notes. I want you to find the range of x if the side lengths are 2 and 8. Find the range of x. So write a compound inequality that describes the range of x. So what is a fact that has to be true?
It has to be greater than 6.
Because,
X has to be greater than 6. Because 8 minus 2 is x minus
right,
6.
because 2 plus 6 has to be what? Greater than 8. So we know 2 plus x has to be greater than 8. So to solve that, some of you are seeing the relationships already without having to do this, which is good. Okay, so we know x has to be greater than 6. Okay, what is something else we have to be aware of?
2 plus 8 has to be greater than 10.
Right, we know 2 plus 8 also has to be greater than x. So 2 plus 8 must be greater than x. So we know that x has to be less than 10. How do I write that as a compound inequality?
6 is less than 1, which is less than 10.
Yep. And then White had a good question here. Will these signs always be this direction? Yes. Okay, that's how the compound inequalities work. They will always be in that direction as long as you have your smallest number on the left and your biggest number on the right. Okay.